Great, thank you. So thanks for the introduction, Max. So as Max said, I look after the ecosystem horizontal enablement for MCUs and MPUs now, actually. And I'm going to talk about some of our newer MCUs and how you can get going with those using RT Thread and our latest low-cost, pretty exciting development platforms in the context of IoT and industrial application development. So if it lets me advance. Okay, so in the Secure Connected Edge business line at NXP, which is what I'm part of, which is separate from our automotive business line, we're focused on industrial and smart home applications. And here we see many exciting new applications and use cases, some of the which are in this picture up on the screen. And what we see universally, though, is that they require smart connected devices that are very secure. And the way we see NXP adding value to the customers is by bringing knowledge in different market segments. This slide doesn't break down all the different details, but the little icons along the top are those end user applications that you guys out there, the customers, are building. And so what we want to do is help accelerate your developments by bringing you integration examples, in some cases full turnkey reference designs, but generally segment-focused applications in that top level 3 at the top there. And these are supported by pillars of technology or know-how in areas like vision, graphics, AI/ML, and several other areas too. And underpinning all of that is our horizontal enablement, or our foundation, and our enablement with RT Thread. We do in collaboration with RT Thread comes into that layer. So how we build things on top of our silicon to enable you to be able to use all the goodies inside that silicon. So I'm just talking about our microcontroller portfolio today. So all this unprecedented growth in all these new applications means you engineers are facing more and more challenge of designing the products for those kind of applications with issues like constraints on power, emergence of machine learning, dealing with legislation, new rules around cybersecurity, etc. And to help you face the challenges, we have one of the widest range of MCUs in the market, and this goes across from the i.MX RT devices, which are crossover MCUs, crossing over from the i.MX microprocessor world into the microcontroller world, and they've proved very popular over the last 6 or 7 years because of their very high performance and their MPU-related technologies. Our newest portfolio, or family rather, in the portfolio is the MCX family, and these build on the lineage of the LPC and Kinetis products that came from NXP and Freescale before the companies became one. But we have 4 series within that, with a lot of expanded scalability comes along with that. Like never before, you can move between a much broader portfolio of devices that are a lot more consistent. We also have other more application-focused MCUs as well that we continue to support, and we also have very good longevity for those of you who may already be using some of those LPC and Kinetis parts as well. But the focus today is really mostly around MCX, and some highlights around MCX then. The MCX portfolio is being developed to satisfy a broad range of applications with optimum price-performance trade-offs and a big focus on low power. So MCX products span a bigger range of capabilities and price points than we've ever had before, as I just mentioned, and bring that scalability to match that. So one of the highlights is around ML and the MCX-N series in particular. So we're simplifying that with embedded neural processing units with tools that enable you to utilize those without having to do any special programming yourselves. Optimized peripheral sets is a real key. So a rich set of analog features and very flexible, smart interface units that help you hook up to all kinds of different interfaces that you may require. And security that range from security that is going to protect your IP up to full security for connected edge devices that need to meet the cyber security regulations. And all of this is fully supported by the MCU Expresso suite of software and tools, and support from our partners, including RT Thread. So you can really utilize all this goodness in silicon with tools and technologies that you're familiar with on the software side. So if you look into the MCX portfolio, it starts with the MCX N series on the left, which offer multi-core performance, intelligent peripherals, advanced security, like I said, those advanced security features to really help the most demanding parts of the evolving cybersecurity standards. Then we have the MCX A series, which covers the widest range of applications and a foundation for intelligent edge applications. So it offers very cost-effective, but balanced with a lot of performance and very capable intelligent peripherals. It also has a capless LDO power architecture, so low cost and low power come together there. We have the W series devices too, with integrated radios. So they offer point-to-point network communications enablement for Zigbee, Bluetooth LE, Thread, and Matter protocols. And then the L series, which are designed for those eco-friendly, very, very low energy systems, always on battery powered with minimum dynamic power consumption. So we're going to focus more on the A and the N series because those have been out a little bit longer and they have boards available today that you can get started with. So the N series, I mentioned dual cores. It's got a lot of different features for acceleration. We have a DSP accelerator I'm going to talk about in a minute, and that neural processing unit, a rich range of peripherals. So you have Ethernet, high speed, A to Ds and D to As, operational amplifiers, comparators, audio interfaces, and HMI capabilities, including DMIC supports and parallel graphics and SPI graphics support. And this is all built on, as all the devices are, on a 40 nanometer process that's optimized for both active and leakage power. And then security-wise, it's PSA level 2 certified at this point, looking to be certified higher than that. We're investigating that now. And we have a high-performance crypto engine, on-the-fly memory, encryption, decryption, and tamper detection. So lots of security features. And then on the A series, really just to not go over lots of details, again, a lot of commonality with peripherals and mixed signal capabilities with the N series, but really address more for the right performance and cost optimizations that you'd be looking for in your systems. So with some more details on the N series capabilities, the EIQ Neutron NPU accelerator is developed by NXP. It's optimized to be very performance and power efficient. And our EIQ tools will enable you to take a TF-like model you already have. You don't need to go and hand code anything yourselves, or even deviate from the source of that model that you may run on just a pure ARM or RISC core somewhere else. The tools will optimize the code for you to use on the Neutron engine. And so it supports all the major NN structures and so on, and has, you can see the kind of performance number you get from this core. So it's very, very nicely optimized for a device of this type. Then we have PowerQuad. PowerQuad is a DSP accelerator. It's enabled through Synthesis DSP API calls, so you can keep your code nice and portable, but also there are other extensions as well to do transcendental functions. And it has an FFT engine as well, and then a set of Cordic functions as well. So this is quite interesting for applications where you may want to do some DSP pre-processing before then applying a neural network, or just pure audio or voice processing acceleration, where PowerQuad, we've seen with our own voice products, we've seen 4 to 10 times performance on audio and voice products that we've developed and offer based on the optimization that PowerQuad can bring. Smart DMA is common to some A and N series devices. So this is basically like some of you might know, the RP2040 has a little IO processing engine. This is like that, but can do quite a lot more than that. So it's a little micro-coded engine which can it can do I/O operations very quickly and efficiently. So you can code it up to do a lot of different things, and you can achieve very, very good power efficiency with quite an intelligent peripheral that way. And what we provide out of the box are implementations that are like smart DMA, and hence the name. And then we have Flex IO, which has been around for some time from NXP. It came from the Kinetis side of things, and can be used to implement a whole range of different standard peripherals, but it can also do custom things, and it can implement things like interfaces to standard display buses, as well as the smart DMA can do that. And it also has shift registers to handle various different kind of custom interfaces as well, along with a programmable state machine. So again, also very powerful, very efficient peripheral engine, if you like. So how do you utilize all these things? Well, we introduced or reintroduced the Freedom platform, FRDM platform. And this was a platform that came from Kinetis a while ago, but we've reintroduced it, updated it. We have things like USB Type-C connectors, a much better debug probe, more expansion connector options, and a price point which makes it very, very affordable for anyone. You can buy it through our website or direct from our distribution partners. You can see the picture here is the MCX 947 Freedom board, and this board has got a lot of capability. Actually, I misspoke. That is actually the A153 board, because the N947 has an Ethernet connector on it as well. So you can also hook up a display to it as well. We have a low-cost display that's about $25, and so you can implement nice cap touch HMI as well as all of that. So very, very capable platform, and supported by RT Thread, as you'll see in a moment. So one of the other nice things about these Freedom platforms is that we have online tools to help you get even more out of it. So we have an application code hub, which is a way to browse through application examples that we have and quickly and easily find what you need as a starting point, and then import that code and get going. You can, it's basically the app code hub is built on top of a GitHub repo, so you can go to GitHub and get the code yourself if you want to go and work with the RT Thread tools directly, or you can use NXP's MCU Expresso Eclipse-based IDE or our VS Code implementation as well. So you have various different options to choose from. And then we have the expansion board hub, which enables you to go and look for all the boards you can add on to one of those Freedom boards to build the prototype system that you need. So a lot of support there to help you out. I just wanted to touch on the IMX-RT platform just briefly, because it is extremely popular. So the IMX-RT devices are flashless, so they're built on processors that don't support flash, and that's one of the reasons we are able to get much higher performance, so up to a gigahertz performance on the RT1170 product, and a lot of high-end features. They have support directly for HMI applications where you have a LCD that's got to hook up directly, and there's also graphics acceleration in several of the parts as well. But they are easy to use parts there, and microcontroller, so they bring a lot of performance that you'd normally expect in a microprocessor instead of a microcontroller, a lower energy budget, simpler design, and still attaining some very high performance. So we're not going to go into too many details on this today, but the kind of applications you'll see RT products being used in is in the audio applications. They're very, very popular in that space, and many HMI applications as well, and motor control, high performance motor control. And then RT1170 and 1160 very commonly used in even more advanced HMI applications, or where you need gigabit Ethernet, and in industrial space they're popular as well. and again, motor control, but this time multiple motors. And then recent addition is RT1180, which is designed for industrial applications. It has a gigabit Ethernet switch built in, so it's quite a unique device in that regard. RT thread support's not there for that yet, but it is in the works. So if we now look at a few application examples, these are some things that our teams of system engineers have built to show the power of the MCX devices. And there are more than this. This is just some of the ones we have. So this one is an anomaly detector for detecting anomalies with a fan, like vibrations or other issues. And it's being built to demonstrate the use of the power quad and the NPU accelerators. So it uses 3-axis accelerometer running at a data collection rate of 400 hertz, and it does on-device training, so it can adapt if you want to retrain the model based on the different setup of the fan. So you can do that on the fly, and with only 30 samples, it can retrain itself in less than a second. And so, as I mentioned, it uses an FFT. It pre-processes with an FFT rather, and then looks for features based on that FFT processing. So a nice use of those two accelerators together and an extremely efficient implementation. And that's how we can get such a good, fast inference time. Here's another one that's kind of a more fun application where it's face tracking using a fan. I'm not going to see it. Yeah, so it gathers data using that smart DMA interface, and then it splits the design up, the face image up, and resizes it, and then uses this face detection model, YOLO V3, YOLO 3 rather, face detection model, and then it can find the faces in 21 milliseconds, and then use a PID algorithm, use PWM to control servos that point the fan in different places. So the fan will actually follow you where your face is. And all of this is done by a single MCX N series processor, no external memory needed. If you think this one looks a bit funny form factor wise, it's because it uses a breakout board that we did before we did the Freedom boards, but same thing will work just fine on a Freedom board. And then our team in China worked on this open ART startup kit, which is also closely associated with real-time, RT thread, and there's also support for the same kind of applications running on our EVKs as well from the RT family. And this is something we're working with universities to help them develop lecturing material and so on, but also can be used for any developer. So an illustration really of some of the collaboration we're doing, and the code and so on that's being developed is available for anybody to use. So it's a nice integration of several elements of functionality that we talked about in the presentation today. So we look at the support that we have on our MCUs. This table is a little bit hard to read, but you can see it's pretty comprehensive support of our most recent devices. So the LPC 5500 series that I very briefly showed on slides earlier is very well supported. And also the RT family, you see all the RT 4-digit products, except 1180, which is, as I said, still in the works. But our headliners today were those Freedom MCX boards. Those are available very cost effectively today, and give you a really nice platform for getting going with RT thread and developing some of these pretty powerful, interesting applications related around MLAI. So in conclusion, we have great BSP support. I didn't mention it today in the slides, but we have a UI design tool based on LVGL, which also is very tied into RT thread, and GUI Guider enable you to do a WYSIWYG design of a UI, generate code that can drop straight into an RT thread application as well. We have our Freedom board program. We have the global design contest we're doing in conjunction with RT-Thread, and more live webinars on the way. So that's what I had to cover today, Max. So I think I've gained a bit of time back for you because I wasn't sure if we would need to accommodate questions. So that's what I have today. There's more information in the slide deck. I think we've provided some additional slides around our MC Expresso ecosystem, but I wanted to keep things focused on that platform and RT-Thread today. So I don't know if we take any questions, Max, or I'll just hand on to the next person, and you can have those 10 minutes back.
Yeah, no, I've just posted a question in the chat saying, does anyone have any questions for you? If people want to ask questions later, do you mind sharing your email with them?
No, that's no problem. It's brendan.slade@nxp.com. So
do you want to post that in the chat?
I will do that. Yeah.
Yeah, make life easy for people.
Yep, absolutely.
I'm well impressed with all the things that are going on in NXP. Recently, I was talking to some of your folks about the radar chips they were making. Again, multiple channels of radar and a little chip about the size of a postage stamp.
It is pretty amazing. I mean, so looking at that, that's from our automotive colleagues, and yeah, I mean, it continues to blow me away. You know, I think you and I are similar kind of age, and you know, the level of integration and capability. It's like the MCX N series. What is jammed into that device is pretty incredible. So yeah, it's exciting stuff.
It is. I mean, I was excited by the Z80 and the 6502. Oh dear.
Yeah.
You tell the young people of today and they don't believe you. Okay, well, Brendan is going to post his email in the chat. So if anyone does want to ask questions later. Oh, hang on. So here's a question. Is it possible to have a collaboration with your company with the university?
Yeah, university programs, because there's so many universities worldwide, we tend to operate those things regionally. So depending on where you are, which university you're at, we need to try and hook you up to the right people. So I think with the Freedom Boards, we do a lot of things. We have the NXP Cup, which is a competition we run every year around autonomous driving of a drone that we have. We do other drone things. And then with the Freedom Boards, we price them at a point that they should be attainable for any student. So the Freedom N947 board, I think it retail price from NXP.com is $25, and the MCX A153 board is about $4 or $5 less than that. So they're very low cost. So it depends on what you mean by a collaboration. So would need to follow up with whoever's inquiring and see what they had in mind.
It's Paul, but Paul, when Brendan posts his email, you can contact him directly, and he can put you in touch with the right university folks and everything.
Yep.
One thing that I've found is that I'm spoilt for choice. Living in America, if I want a board, I can just go through Amazon or something, have it within a couple of days. But I've got friends in various countries around the world where import taxes or just things getting lost in the post make it incredibly hard to lay the hands on hardware. So,
well, I think the days that a few years ago, that was definitely true. It was a bit of a nightmare to get a hold of boards. That situation has ended. So, you know, we have distributors around the world, the e-tailer type distributors, the likes of DigiKey, Mauser, Farnell. They can get you a board very, very quickly. You can order from NXP directly, and we'll ship them. We're not as fast as them because we have a Malaysia warehouse where things have to come from. So that takes a bit longer. But, you know, there shouldn't be any problem with boards being lost. We use FedEx or whoever. So it's all quite traceable. So it shouldn't be too hard now.
Okay, well, I didn't want to pick any countries out, but there's somewhere I just literally cannot send even a paperback book to a friend because it never gets there.
Yeah, there are. I know there's some countries where it can be more challenging. Yeah.
Well, thank you so much